Lawrence, thank you so much for taking the time to present here. Lawrence is the CEO and CTO at Nika, which is a Singapore-based geospatial company. So they're doing a lot of work on improving the workflows using AI agents and Nika infrastructure. So he's gonna be talking today about all the cool stuff he's doing. Over to you, Lawrence. Thank you.
Yeah, thank you so much for introducing. Let me just see how I can share the screen. All right, thank you so much, guys, for coming. I guess good morning for some of you, good afternoon, good evening. Thank you for having this wonderful session. I think it's the first time presenting here in this working group, and today we'll be basically talking about the up and coming thing of AI. Analyst agents, and especially in the field of geospatial and of science. And beneath that, we need to also talk about the kind of geospatial data infrastructure that powers and houses these AI analyst agents because the data set is getting larger and larger. So without further ado, let me just go into the content. So here's me. So I'm here in Nika, heading the research and the technological development here. Actually, I have my co-founder here as well. I should introduce him a little bit as well. So we were both, we both head of our job at Amazon Web Services after we first graduated from school, and over there we were working with some of the government projects in terms of building a big data platform that they can use for Singapore and the US government. So that's where we met, and then we basically figured out there's a lot of rooms that is actually having a big room of a gap that people actually facing right now in terms of having all these data sets, but they can't really have like an efficient tool that they can actually make it work for them. So in 2022, we resigned from Amazon Web Services, and then we founded Nika here in Singapore that focusing on geospatial, spatial, temporal AI, and we also secured fundings from VCs all across the world. So in these 3 years, I would say that we did fairly a bit of good work in geospatial. So we were, actually, climate startup competition winner in COP29, the climate conference, and then we were also selected the top 5 in Temasek Livability Challenge in 2023, featuring some of our geospatial work. And I talk about some of the geospatial AI stuff in Force 4G in both Thailand and also Australia in last year. And there's a lot of focus here. Even within the company, I think everybody is all like really, really techies. We code a lot, and we have completed a lot of contributions into open source projects. So even myself, I code about 300,000 to 400,000 lines of code every year nowadays. Of course, with a little bit of help from AI, and I think. We are actually seeing a lot of really, really good work in the geospatial community. So we just want to be part of it, right? So there we go. And this is my co-founder Johan or John. He's also here today in this session to help me answer some Q&A questions later on. This is us basically winning some of the challenges, and we basically think about we strategize, and we think that we should be the geospatial intelligence partner for all researchers, individuals, enterprise, and governments. And so far we have been working with quite a number of companies and groups that includes Blue Carbon International, Singapore space agencies and stuff. Yeah. And I think when we first started, the biggest challenge we faced was geospatial data is just exploding, I would say, and this is basically non-stoppable. You have different kinds of satellites being, sent to the space every day, almost every week. And as of recent, we are seeing new satellites being launched. There's ones from Planet Labs. There are ones also from different different companies and through the use of SpaceX and other kind of companies, they're sending them to the space. And these are always, sending back data, and then these data get archived and then eventually used for analysis, right? So as of 2024, this is standing at a petabyte scale, and who knows, you actually go a lot more, and there's just vast amount of data sets that's left there that's need to be tapped on, and if you see this scale, the volume of Earth observation data has increased from, I would say, in this case, like next year, about 400 petabytes, and projected to be soon going to be 600 petabytes, and who knows, very soon you'll be exabytes. The more stuff we have, that's actually flying above our head. And in terms of individual level, so when we look at the individuals who are working on drone image processing pipeline, this is what we are looking at right now. So it's very easy to see somebody working with 3 terabytes of data from different drones, DJI, and other kinds of drone data stream in, and then they need to process this amount of data on their like urban, agriculture, and other use cases. But very soon you'll be seeing a lot more data sets coming at a higher resolution, at a higher, more bandwidth and stuff. Going from multispectral, maybe going to hyperspectral, and it's just going to be getting a lot challenging. But on the other hand, I see when we also use some of the tools that's existing out there, so we actually struggle a little bit. These are really like powerful tools that we used years ago, but nowadays when we try to put in a lot of features in the polygons and stuff, it basically will hang a little bit, and then sometimes when you're trying to run some Juul processing, it may get stuck, or you have to wait overnight. So it's typical. I remember John and us were in the office, and we have to put a computer basically overnight over there for it to finish, and then when we come back in the next morning, it just got completed. Yeah. So there's that, and suddenly in 2023, we entered into a new era. Guess what? ChatGPT just launched, and they hit 1 million users across the whole world within a week, right? So at the time, so we were basically, had a discussion where can we use AI for spatial work, and if you do, how does it perform? So we went ahead, we tried doing vegetation cover analysis using ChatGPT, and it's basically going to search the internet and just finding some available websites, and then basically give you a summary table, and that's it. But it's not really doing any form of analysis work, and following certain kind of methodology. So I guess the ones of you that have a sharp eye, you realize actually, this is a free tier. So we actually went ahead to try, cloud with the pro tier. Maybe thought that you can do better. But if you see over here, yes, it does a lot more in terms of doing research, but still, it is basically just still researching on the different data sources and pulling them and trying to read through each one of them. And you can see all the sources is actually referencing, and to get the vegetation analysis, cover analysis over here. But towards the end, let me just skip to the later part. So you'll see that it just keep on going and continue until it still summarizes the different data sets it has, and then just give you a summary based on the different kind of resources that you put in. So this is very common, because if you understand transformer models, that is the base of all these LLMs, right? They are basically just working on probability models and regurgitations based on whatever data is being trained. So there's no like real-time processing layer that's able to handle that kind of stuff. So over here at Nika, we thought about it very deeply in the past 2 years. So this is basically our thesis over here. We believe that large language model plus the modern geospatial libraries will be changing the game in terms of analysis. So I'm just naming a few of very popular libraries that is being used right now, and we also users of them internally. So you have HDF5, you have ZAR data cubes, and then using Xarray to interpolate them. You also have PyTorch, TensorFlow kind of machine learning framework. You have IceChunk for data management. You have Sedona and Spark for data analytics, geoprocessing. So these are wonderful tools, and there's something we find in common, that is they all have your Python interfaces, and it basically allows the AI to code in Python and being able to do the analysis that it needs to achieve. Yeah. So yes, so we have AI that now can do coding, but the problem is it's like brains need brawn. So I'm a big fan of LeBron James here. So you can see that he being a very intelligent NBA player, but he can't just be just because he's smart. He also need to be very fit. Has his fitness, physical strength, being able to come back from very challenge and very lengthy games, and then still be able to dominate them. On the other hand, if you're talking about the future of geospatial AI, I think the large language models, is getting stronger and smarter day by day, right? So you have Claude 4, and also GPT 4.1. Very soon you have, maybe GPT 4.5, GPT 5, and Claude 4.5 or Claude 5, right? So is there just going to be putting more data, more parameters, and then knowing a lot more knowledge about the world? But the problem is it needs a muscle to also be able to tackle that large amount of data we talked about earlier, and also being able to know the latest functioning, or even best example of code, right? If not, it's not going to really run the kind of analytical work that we do on a daily basis. So here's our solution that we have been building for the longest time. So I'm going to introduce our own data infrastructure, and so we built NikaPlanet. So we position these as an ArcGIS Pro alternative. ArcGIS being a very good software, so we have been really learning a lot of the good side they do. So here's what we do here. As you can see, on the first thing we built was actually a GIS optimized VM. So I'm not sure how many people actually here actually use GDAL and also CUDA. So if you do, GDAL is fantastic, right? It's basically the backbone of a lot of what we do. But GDAL is very hard to install if you are trying to install GDAL in a Linux system or in your own Windows terminals, right? So here's what we do. We inbuilt GDAL into our own VM virtual machine. So it's like you go into your Jupyter, but you don't have to install GDAL because it's always there. Have the different versions you can choose from, and if you're doing machine learning, you have all the the CUDAs, libraries, and dependencies that you can rely on, so that you get your PyTorch and stuff can just work seamlessly without having to do anything. The second thing we did was we built the unified data lake structure, where you can put terabytes, even petabytes of files in theory. And when we try with customers, they put 10 terabytes of images, and then they have the machine, the VM can basically tap onto all those data seamlessly without any delay. And they're able to train the models in the code, as you see in the middle over here, very easily as well. So all those data, any changes happen in the file will be reflected on the left as well. So you have an interface where you are basically having your own little vault, and then this vault is so powerful that you have everything just integratable with them. Yeah, and we also have a lot of struggle before this, that I have the code, I have let's say Google Colab, but I can't really visualize my stuff my large data sets on the map easily. So we also built the visualization engine on the right over here in number 3 that you can see that it's just going to allow you to drag and drop any vectors or raster images in as well. And then you can share this easily by clicking the buttons at the top right. And then lastly, we built our own AI agents, which I'll talk about later on in this, into this entire platform itself. So in the past, the platform was first, trying to tackle some of the vector stuff. So now our users can go in and visualize, in this case, 1 million polygons. They can visualize them. There's no delay and no lagging, and they can just double click and then start, going and edit them. And they can basically, move it around, change the vertices, and then drawing new ones. And all these are happening, within a second. Yeah, as you can see. On the other hand, so we also try to do some kind of vector functions on the reforestation stuff. So because reforestation has a lot of polygons and stuff as well, that you do need to make sure that that's basically a seamless process over here. So we do run an area of interest, and then we can do a buffer. That's what you can also do in QGIS. And in this case, we just make it supported natively. And you can see that we then use this area to do a lot of like data, vector points and stuff to show as a result of our study. And on the other hand, so there are also a lot of people that's doing raster stuff, even our team. So we need to visualize, and style GB size raster images in the single interfaces. So you can basically piece them together. As you can see on the right-hand side, there's going to be different kind of representation. There's a RGB channel, there's single channel, there's also the NDVI kind of composite channels as well, that you can basically choose from, and then changing the color map. And to show you how we have been using it, applying. So this is an example where you can basically write a code in the same interface that has GDAO and CUDA being installed already. You can just write the code and run them. And then essentially you have the data that's being output. You can just drag and drop into the map. That's a raster image over here. You can change the scale to compare the, redo the contrast for this population density map that we have over here. And then beneath you have the vector data that's also for the same area. Yeah. And how we did that is that we have our own data lakehouse infrastructure, where you can put in, just dump all your drone images, satellite images, ground surveying, CSVs and stuff. And all this stuff are, going to coexist in a common space, where then you have all your compute and stuff able to tap on them almost immediately. And the thing that we have to do a lot of those heavy liftings. So those things, we're already taking care of them. And then, the most important thing is that we having them to be able to tap on your the future existing data structure as well. So if there's people that come with a database, it can easily be integrated with their Postgres, DuckDB and stuff, and to be able to extract certain data tables as well. And also, of course, DuckDB is also up and coming, and then we really it's a very, very good tool for Geospatial, and I talk about it a lot. So this is the overall, landscape that we have been using our own data infrastructures across government projects, and then we have thousands of data integrated, and we have VMs that has both CPU and GPUs can spin up in 10 seconds. And then sometimes users do come with certain models that they want to deploy them, so they can just one click and deploy the model. Or once they have the model being deployed, you'll be showing in their interface that they can just one click and then inference on the model they deploy to test the efficiency of the model. And all these are running on our compute and system, so that they don't need to worry about managing all those. And then I think coming the interesting part of today is about geospatial AI. And let's first review some of the very promising existing geospatial AI approaches. So one of the things here at Nika that has been following a lot is the large foundational geospatial models, and there are some certain there are many players that are trying to convert your satellite data and drone data into embeddings, and then these embeddings are going to be in the very large foundational model, and they can use these to compare different places. If you have let's say a windmill, you can use models like clay, and then just ask it to find you other windmills around the world as well, because it has been trained with the locations and also the locations associated image data itself, right? And there are even a lot more models. I won't be able to name them all, but there's also the limitations as we try some of them, is that they tend to be still task specific right now. They can do something that traditional machine learnings can't do. I really think that's really, really promising. But then when it comes to being doing a lot of generative stuff, being able to do a lot more than just the task that it's been trained on, then I'm seeing some limitations over there. And also, if you throw your own data sets to give to the model, you can't really use that. And then if you try to throw a code to ask it to modify a code, of course the geospatial foundational models won't be able to, but the large language models will be. Yeah. So there are companies, great companies like Google. Their research team has been, advancing in these areas where they're trying to put, large language models and then, train them up with multiple, geospatial foundational models as well. So that you can basically, understand your queries in natural language, and then knows, what kind of orders to give to the geospatial foundational models to then run to give your analysis results, versus you having, to do that, in the past. I would say that's really promising and up and coming. And alongside that, Nika is going to take a very similar approach, which I'll explain. So in this year, actually, just last month, we just opened our beta for Nika's own geospatial AI analyst agent. And as you can see, the acronym, we actually call it Gaia, and the GeoAI, which also happens to stands for the goddess of Earth, which I think is going to be a very interesting representation. And here's a little bit of demo that I want to just quickly show you that what Gaia can do. So I'm here asking Gaia to calculate the population density for Jakarta's suburb area, and it basically fetches first the boundary, the geo boundary, and then it fetches the different associated data sets, like in this case I think it uses land scan, because we have a vast pool of data that it actually knows about. And in this case, it just code out the code, and then it self-rectifies the code until it actually works. So then the results over here, as you can see, have the different density maps in Jakarta, and also give you this data. Of course, you can prompt further. You can say, why not you can create the a table for me, or maybe a chart for me from here. It also do it for you. So after our launch 2 weeks ago, I think we got a lot of signups to try Gaia. I would say this is like a perfect agent yet. We still have a lot of work to do. So John and I, we are still grinding a lot every day in order to get it improve over the days. And yeah, so if you guys are interested, we can talk about it later on. And here's the key innovations of Nika Gaia. Just want to explain to you why it is going to be better than just using any other agent. So first, we have the geospatial VM that I talked about already. But on top of it, you have so many other data. And how does the LLM knows which data is the one you're querying? And if your data is very, very large, has a 300 megabytes or maybe 1 gigabytes, right? Feeding all this data in the raw formats to the LLM, it actually doesn't make sense. So what we did was we have a file indexing system that's going to find the right data, the right file that the user might be referencing. And then at the same time, we also condense that the different formats like JSON TIFF to the level that LMs can easily understand what this data represents in a spatial context. And on top of it, we also feeding hundreds, actually not hundreds nowadays. We increase to thousands of data sources, including the public ones like Google Earth Engine, OpenStreetMap, Overture, and we also going to integrate commercial ones that users do want to choose to work if they are willing to pay. And second last, we build a self-healing system where the code that's been generated by the large language model can be wrong at sometimes because they do hallucinate. But we do have a checking system that can check both the syntax error and then the runtime error of your Geospatial Python code, such that then the users is able, the AI is able to then rectify until it works, right? And most importantly, we have different large language models for users to choose from. So as of now, there's an 8 that includes your GPT 4.1, that includes your Claude 4, and also Gemini 2.5 Pro. And I would say each of them having a different strength. And that's always great because then the users can go on and try different ones that may work for them for the different data sets or different workflow. And beneath all this, we've been building a multi-agent network that basically works pretty seamlessly. So at the core, we have data search agent that's able to process and validate any incoming geospatial data and then make sure they're always up to date. And then on the file side, we have a files agent that's able to provide the right context about a certain files the user has in the system and then be able to let the AI be able to work on them. And there's also spatial function agent that performs different complex analyses and patterns. And then there's also a map agent that's is still work in progress. The map agent will be able to generate and understanding some of the map layer stuff, the styling, and then be able to manipulate the map layers as accordingly. So here's basically how we were trying to measure the end-to-end efficiency. We give, I think for now we create about 100 different geospatial use case and workflows, and that includes the common ones that we see. And as of before the launch, I think we have about 41% of accuracy from end-to-end that allows you to complete and then give in the output that users needs. Then we also improve the system as we continue. So as of today, it stands about slightly over 60% of end-to-end completion. And as we continue on to improve the system, making the agent more robust, we do see going to increase in terms of end-to-end completion rate, and then be able to help users from the middle part where users might be writing some code and then just use Gaia to modify the code for them, solve some bugs, resolve some issues, or be able to fetch the data sets that users actually don't know, and then find out the different, compare the different data sets until it actually works. So that's how we basically measure them. And but there's a lot more rooms that I think the Geospatial AI community can improve. And that's the reason why John and we are here today. We are looking for people to to try out and also collaborate on certain opportunities that you see. So there's different ways that we see can move Geospatial AI community a lot more steps forward. That includes making the research work to be not just in the single laptop, but actually make it go into a much wider audiences. And we have also been hearing people are looking for data sets as we are showing them Gaia. So actually data sets generation is something that we actually care a lot over here in Nika. So we were just thinking, why not you can use Gaia to generate data sets for the specific use cases that may not exist today, right? And then we can you can co-publish them so that people in the community can just use it. And there's also areas where they can be collaborative studies, and also where you can create reproducible research and data results to share to the open community. And some of the work that we have been already doing and building here at Nika includes, building an object detection model that over here to detect the houses and then basically segment it out on this image. And we also built a water quality model with some of the institutions. And in this case, it's basically trying to do the water turbidity. And what used to be, what the institution used to take was about 2 months. But after our team uses NikaPlanet and then uses Gaia to improve the whole workflow, it actually got down to about 30 minutes for these kind of sizes of area that you're looking at, and having a very large area to be able to convert it to raster that contains your chlorines and different kind of water turbidity metrics that allows people to identify from the area. So that was really impressive on the other hand. There are other things that we built, but we just can't showcase them all. That includes real estate insurance, that includes forest carbon sink, that also includes flood predictions and early warning models. Okay, and of course, one more problem that we face today is how do we really benchmark and eval geospatial AI as we go on. So traditional ways of metrics we are looking at are like accuracy, precision, recall, F1 score. These can only show the core capabilities of an agent when you are looking at it in the research standpoint. But there's a lot more like your business outcome, there's cost savings, operational efficiency. There's many other criteria that will be able to compare different geospatial AI solutions out there. And so we are seeing some common approaches, like people are trying to use multi-agent bench or tall bench. These are the benchmark that uses a real life task query in order to see whether how well does an agent perform. But this is still not really into geospatial at all. It's basically just any general real world task, and we are just looking to build a much better version that can see how well the world has been improving around geospatial AI. And on the other hand, there is also a lot of security safety concern. So I think security safety are also a key metrics that need to be embedded into the benchmarking as well in the long run. So that's it. So we are here very happy to take on more questions, and our goal here is to accelerate the earth science altogether, and then building wherever we have been building in the last number of years can all be taken out and put into different research efforts, put into real world use cases to benefit humanities and climate and the much wider audiences altogether. Yeah. Thank you.
Fantastic. Thank you so much, Lawrence. I think there's a question on the chat. Ben is not here right now, but it looks like you already have some collaborators who's willing to work together, so that's great. Tim.
Yeah, fantastic presentation. Really, really cool stuff. I've got a bunch of questions. I don't want to eat up all the time because I know there's others. The first question I have is, how does this group get engaged? Like, what is it? Because we've got a lot of people who attend these calls who are maybe interested in exploring things. Maybe there's a way in which we can link folks to do some trials for you, or just get some feedback. What are your thoughts on how to leverage maybe this group and some of our interests? Because I think this is really overlapping with a lot of the stuff that our group is interested in.
Yeah, that's a very good question. So I think at the top of my head, there's a few areas. So one is having, I would say, having interest. If people are interested to use what we do, what we built so far, we can talk about having them to have the better access and then start trying and see how these can be benefiting. But in the long run, we do also want to just build the community, right? So it's something that our vision is to have a common hub where people are able to share any of their GeoAI, results of whatever they have been building. And in the past, the process of doing so is a bit, I would say, cumbersome. It's not non-doable. The professors like Dr. Wu, they create the different kind of models and the different kind of results and apps. He'll post on places like Hugging Face, and then he'll post like a small little app, and that's what he used to do and still doing. And I really think that should be the common practices that we can all embrace together, because then we can have a common place where we all sharing all the geospatial results and work, and in the form of data, in the form of maps, in the form of the whole solution suite that includes both data, your scripts, and also the maps altogether. So that's something that we are building and make it easy for people to share. So yeah, we're also calling for folks to do some of this stuff that's being able to share with the wider public. Yeah.
Wonderful. Yeah, and I've got two more quick follow-ups. I know I don't want to use all the time for questions, but I'm inspired with a couple questions here. I'm just going to send some links into the chat here. Sam Roy, who attends a lot of these calls, and he's a fellow a Google developer expert with Biplav and I and Emil and a couple others on the call too. He's doing a search function for a lot of the efforts that he's done with the Google Earth Engine Awesome Data Catalog. So if you guys haven't talked, I would definitely maybe connect you guys, because that's a really interesting repository, and he's approaching it from a sort of a similar landscape, not in a whole platform, but data search is a huge question. So I'm happy to connect you guys, because I think it's an interesting opportunity. And the other thing I was going to mention is really pick your brains on existing workflows. So what you guys presented is like a really comprehensive platform that goes end to end, but a lot of folks have workflows that they've already adopted, or they're organizationally adopted in some ways. And I'm imagining not necessarily a full adoption of a whole platform, but how are you envisioning a way in which there may be like a model context protocol, or perhaps like a endpoints that parts of your platform are available for people to take components that they like into their workflows? Do you see that as an opportunity as well? And just like, what's the level of flexibility that you're thinking about? Because, just my own perspective, like we've got all these tech stacks that we're wanting to use, and if I could take elements of it, that could be really beneficial too. So kind of an oblique question, but I wanted to get your thoughts.
Yeah, very good questions. I also, one by one, I think we also watched the demo from the Summer Priya on the GE catalog searching using like GPT, I think at the time. It's really, really cool. I think that also helped to give us maybe embedded the seed in our brain. Like, okay, having the data search is going to be the core of earth science acceleration, right? So that's what we did, and definitely happy to talk to him. You'll be our honor to talk to him and learn from him as well. On the second question about having the workflow and be able to share, let's say, open some part of our core technologies to other people to use. I would say definitely there are ways of doing that. So I just don't know what's the best method as of today, right? Because if you're talking about an API, so we need to like study the actual how an API can be designed in a way that best benefit people, and that's one. The second thing is if we are opening like one part of it, and the folks actually use it in their own environments, they actually can't use it because it's kind of complicated. As we design a way that's actually working with like in the tens of terabytes of data at a scale, we actually didn't design it to work in your like one computer because we need to make it scale. That's where the geospatial heavy work is actually happening right now. So that's that. But it doesn't mean that we can't condense the version that we have been building in our brain into something that can be working in a smaller scale. That could be something in our pipeline that I can discuss with John later on, and still having people to benefiting if even if they don't have a such large, a scale of workload that they really need AI for it. Yeah.
Yeah, maybe I'll just chime in here also for a second, Tim. I think that's a really good question. Maybe to help you understand who some of our users are, most importantly, so that you guys can understand context. Most of our users actually are migration from ArcGIS Pro and Esri kind of existing users. So imagine basically, for example, one of our largest customers is the Singaporean government. A lot of them used to be on the Esri stack. I think they're moving a lot heavily into GeoAI. I think you guys know Esri I think is amazing for quite a lot of things. I do think in some areas of larger scale GeoAI, from raster processing to raster visualization, they tend to struggle in. So for us, it was taking a lot of approach from those customers, and for them, they really needed a kind of end-to-end type thing, typically more of a migration play from their existing ArcGIS solutions to something that's more suited for the type of workloads that they're performing. So that's kind of the, I guess, why we built in this directions, because that's where our customers needed. We did have a lot of requests very recently to, for example, like a lot of people want our visualization panel, visualization engine to basically, I think it's quite challenging to basically edit, for example, 3 million polygons on your browser, on the fly. That's something quite a unique feature of that. We haven't built an API for that yet. Once again, we're kind of growing together with our core users and customers, but that's definitely something we're very interested in building out in the future, I think, as Lawrence had mentioned. But that'll be a really cool part maybe in the future to think about how we can further break down our technology to make it a lot more accessible, a lot more modular on a more API basis. But that's something maybe coming in the future. But for now, our customers are a little bit more they want kind of end-to-end type solutions. Those are kind of our core users for now. Yeah, I hope that answers that question a little bit more as to why we built in this direction.
Perfect. Yeah, that makes total sense. And thank you guys so much. And I'll pass it back over to Pipwal because I know there's more questions.
For sure.
Thank you. Are there any questions for John and Lawrence? John, maybe or Lawrence, you can talk about some of because I work with engineering company. So is there any provision for enterprise to get involved with what you're building? Are there any pricing structure or anything on that front?
Yeah, for sure. I mean, our other larger kind of government still our largest form of kind of customer base. But we do work with quite a few enterprises as well. That's something we can discuss kind of separately. We do have different enterprise tiers. We charge based on compute with kind of a minimum pricing license, and then it kind of scales from there. But obviously, if you're a larger government enterprise, there can be typically a lot more customization might be needed on those packages. So that's something that we can also discuss. But yeah, typically we charge based on kind of a mixture of compute and storage.
Got it. And what kind of data sets you currently host? Are those mostly open data for now? And if there are, different kind of data sets, for example, drone, LiDAR, or even aerial, which are, very high resolution and requires a lot of space. Do you guys also help hosting them, making them accessible in a cloud native format?
Yeah, that's a big part of the work we do. For our government clients, so I think, I guess because NikaPlanet has to be deployed on quite secure environments for governments and that sort, with very controlled user access controls and those type of things. For our government customers that deal with a lot of satellite data, there's direct integrations to their to their own private database, and also to their own authentication to their own satellite data pipelines that they have with different commercial providers from your Maxars, whatnot. So those are perfectly integratable, working with our team. But those are typically from our own more enterprise level customers. For our generic NikaPlanet users, kind of on a normal level, we have set up a very nice integrations with quite a few of those open source data sets, from your Sentinels to very, very easy query from directly those S3 buckets. Lawrence can just show you. Yeah, you can just draw a simple shape, basically choose whatever data set that you want, and then download the data or visualize it directly kind of in your environment very, very easily. Or you can use the notebook to basically API your Google, I guess, GAPI or API, whatever your Sentinel hubs directly into your own environment as well. But yeah, the data hub is kind of just a nice, quick way for you to also interact with more open source data. I think Lawrence is just showing you a demo right now. Yeah. Yeah. This is just a live demo.
Yeah.
Yeah. I hope you can see just how quickly it renders.
Yeah, there's also Sentinel and everything, and then we have like ability for users to just download the data, into the drive, which is on the left over here. So they can just download the data, or they can just visualize it like what I just showed you guys earlier with just a few clicks. And then there's downloading, and then you can select the bands. And for visualization, you can select an area that you have selected to draw on a map, and then that's how you can straight away visualize them. You can do both, and even if we don't support some of the data sets, that users might be looking for. Let's say they're looking for like these data sets. You can see that it doesn't exist here. They can still do in the code though, right? Because it's happening in the interface over here. The user can just run the code and then download into the storage, which then they can just do model trainings and whatever, and even add to the map easily. Yeah.
Very cool. Before I hand it to you, I think there's a question on the chat from Anastasia. I don't know if Anastasia, you're online. You want to ask the question or?
Sure. Yeah. Really great presentation. I just wanted to ask about kind of what's next, what other AI tasks you hope to enable on your tools. And if there are any specific kind of data sets that you hope to specifically use to better train or like test your architecture against, if you think it would be more of a challenge and you want to like surpass that.
Yeah, sure. I think I can talk about the data sets first. Some of the stuff that we are integrating next that includes human data exchange and a bunch of others which are more vector data source providers as well. The challenges we face is definitely that like it's just so large. If you go to data human exchange, you can see there's 18,000 plus data sets and it's growing in size. So there's definitely quality problems. If when there has so many data with for the same purposes, right? It's very hard to discern and understand which data is better than the other. So that's definitely posing a challenge in terms of making sure the entire agent is working properly. So that's one challenge. I can easily share that because we're just working on it at the moment. And in terms of future, what's next coming? Are you talking about the features, or are you talking about the industries or use cases?
I would be curious, feature-wise, what's coming next?
Yeah, feature-wise, I think one very, very important thing is to be able to first be able to run a workflow even in the back end, and then having it to be running until until it actually works very well without actually running in the UI. That's something that sometimes you just want to do your own work, and then you get the Gaia to just work in the back end, and then alert you notify you when it's been done, right? So that's something over there. I think we'll be interested to see if people actually want that kind of feature. So yeah, happy to discuss if there's something along the line that you guys are thinking of.
Great, thank you so much.
Cool. AZ.
Hey team, yeah, pretty neat demo. Just wondering, I don't know if I missed this part, but because you're kind of sharing this as a data infrastructure, do you run this right now? Is it like focused in Singapore, or is it open up to other countries? And how do you, or do you have a process in place for co-locating the data within, say, countries? So say you can't take some data outside of say, Australia. Do you kind of host the data? Do you host the whole infrastructure? Is that kind of how you're representing this? And yeah, how do you kind of deal with some data privacy and various other bits and pieces?
Yeah, thank you, AJ. That's a very good question. I think maybe even helping other people here to understand. So John and I, we actually actually created our job together from Amazon Web Services. So that's where we were working with governments on sensitive like data platforms that has have to work with very sensitive data at the times, and they need to do analysis on them, right? So that's definitely a very common challenge that about data sovereignty issues. Where do we house the data? Where do we host the data? And making sure that it's secure and also meet the compliance of the different teams and requirements. So we actually built our whole infra with that in mind since the start. Right, so John and I, we keep talking about, what if the user requires the data to be only in, let's say, India, or maybe because of the government law over there, or maybe the data has to be seed in, certain regions, let's say Gulf Cloud region in USA, for example, right? So even though we were started as a Singapore company, because that's where we were born and live, and we need to make Singapore proud, but also we have the heart that we have to go international since day one. So there's data sovereignty, and we have the choices for institutions, even for our platform, to be able to make sure that their data is only seated in the data centers in their country. So we are leveraging like a multi different like cloud service providers like Amazon and also your Google Cloud. So they have data centers in many countries that that's meeting the locals like your government standards. So basically, there's that choice in terms of where you want your data to be seated and meeting that requirements. Sorry, my answer is too long, but does that answer?
Yeah, that's great. And are you still, sorry, just a quick follow-up, and are you still using like a public LLM, let's call it a public LLM, or are you using like your own LLM? Like, because if you're using a public LLM, then don't you need like some sort of an enterprise agreement and whatnot to ensure like maybe your data doesn't get used for something else, right? Like for like Claude's training or ChatGPT's training, just as a,
Yeah, very, very good question. So I think it's actually, I think I get it, right? GeoAI, working group, right? You need to talk about AI. So it's very, very good question. So first, we are using public ones. So the public ones do have the service level agreement and then also the API. And the good thing about that is you always get to use the latest version. So we don't need to manage a lot of infra. And of course, when we do that kind of service agreement is usually when they can't really train or use the data, or maybe the chat history that is from our platform. So that's if they don't do that, then companies like us or Cursor AI or Lovable, we won't even want to choose to use work with these companies, right? And if our users feel like the certain companies like OpenAI or others that they don't really like, they have the choice to not use them also. But hearing that, I think there's still concerns in the future. So I think one way to solve that is also to use local hosted models. That's also getting very powerful. So DeepSeek being one of them, and of course you have Meta in recent days actually gathered all the top AI talents, if you read the news, from like OpenAI and all these companies, right? So then they might actually building a very, very robust models like Gemini 2.5 Pro that's actually able to catch up, and then we just need to benefit by actually deploying that models in the local secure environment. But then maybe some other people will then challenge and say, oh, so you have those models like DeepSeek. What if the model can come in with malicious design in it, right? Maybe just like when it does something, it just automatically like sends your data out, right? So there's always endless things. It's the same as security, right? We have to come up with ways to guardrail and interoperate and making sure that does not happen. Right, so there's definitely going to be loopholes, but if you don't build it, you will never have it. But once you start building it, you need to actually start to advance in the area that's actually going towards safety, going towards security. Yeah, you need to do. Then you can have like your different measurements and your different ways of rectifying and ensuring it's actually always got real. Yeah.
Cool. Thank you.
Yeah, safety and security is always a concern, and been using the models locally, at least hoping that the data are not outgoing or whatever. Thank you so much. I think we're at time. John, thank you so much for sending the link to the sign up for the beta user. Just make sure you're from the GeoAI working group, and they will bump you on the waiting list. Otherwise, thank you so much, Lawrence, for your excellent presentation and discussion, and thank you all. We'll see you all in 2 weeks.
Thank you. Yeah, have a good one there. Bye.
Great talk.
everyone.
Thanks.